In this particular question, we've been given the cubic function f of x, which is equal to x cubed plus 2x squared minus 4x minus 2. And we're asked to find any points of inflection and determine where the function is concave upwards and where it is concave downwards. We start by taking its first derivative, f prime of x, and we find that it's equal to 3x squared plus 4x minus 4. We then take its second derivative, f double prime of x, which is equal to 6x plus 4. We're using the second derivative because we know points of inflection occur when either the f double prime of x is equal to 0 or f double prime of x does not exist. There's also another condition that has to be maintained for a point of inflection, and that is that concavity changes across that point, which will be something that we'll check later in the question if we indeed have any potential points of inflection. So in this case, we're going to set f double prime x equal to 0 and solve for x, and we find that x is equal to negative 2/3. We would then take this x value, substitute it back into our original function f of x, and solve for the corresponding y, or f of x. And it would be 34 divided by 27. So we're not sure at this point if this is indeed a point of inflection. Sure enough, f double prime x is equal to 0 when x is equal to negative 2/3, but we don't know if the concavity changes across that point, so we have to still do a little more work. The next thing we're going to do is put down our number line and write the value negative 2/3 on our number line. We're now going to test our second derivative, f double prime x, which is equal to 6x plus 4, at x equals negative 1 and x equals 0. I've chosen x values on either side of negative 2/3. I could have chosen any other x values on either side. For example, I could have chosen x equals negative 2 and x equals 1. Those two values are on either side of negative 2/3. When I take the x value of negative 1 and I substitute it into my expression for f double prime x, I find that f double prime x is equal to negative 2. So I record that on my number line. Then when x is equal to 0, I find that f double prime of x is equal to 4. So I record that x values greater than negative 2/3 produce positives, and I've indicated that with a little positive symbol on my number line. Well, we know that a function is concave upwards when its second derivative is positive. Therefore, we can conclude that this function is concave upwards when my x values are going from negative 2/3 to positive infinity. A function is concave downwards when its second derivative is negative. Therefore, we can conclude that this particular function is concave downwards when my x values go from negative infinity to negative 2/3. The last thing we have to consider is the point negative 2/3 and 34/27. Is that a point of inflection? Well, it is, because concavity changed across that point.